Alrighty guys, welcome to the chapter 5.1 homework. Alright, let's get started. Now the first question is asking us to determine which term in the entire polynomial will basically give us the picture of the whole graph. And if you guys recall from the lecture, that's going to be determined by the leading term. Now the leading term is the term with the biggest exponent, the largest power. So since in this particular equation, 7x to the fourth power has the biggest degree or biggest exponent, we're going to say that's our leading term. So the answer is going to be, I guess the last choice, 7x to the fourth for us. Alrighty. Next question is asking us to, okay, so I'm not going to go ahead and, but similar. It's just asking us for the name of what we call, the name of the thing that we call that the solutions are repeated. So let me go ahead and just make an example of that. If I said to you guys y equals 2x plus 1 to the third power, we're going to say that the solution is -1, but it's repeated 3 times. Because remember, x plus 1 to the third power means x plus 1 plus times x plus 1 times x plus 1. So instead of saying the answer is -1, comma, -1, comma, -1, we're going to say the solution is -1 with a multiplicity 3. Okay? Meaning it's repeated 3 times, right? That's what it means. The solution works 3 times. All right, so we're going to say that's multiplicity. Let's clear this and move on to the next question. Draw. Okay. The next question. All right, so how many turning points possible does that polynomial is able to have? Well, the number of turning points any polynomial is able to have is going to be whatever the degree of the polynomial is minus 1. Now, this is the max number of turning points. It doesn't mean it has to have that many, but it can be up to that many. So in this case, for this equation, the degree is going to be 6 because if you look at it, that has the biggest power. So my degree is 6. We take away 1. This equation could have up to 5 turning points. It could be less, but it has up to 5. Now, remember, when you have the max, it can always go down by 2. It can be 5, or it can be 3, or it can be 1 turning point, but it can't be more than 5. So that's the idea. So we're going to go ahead and clear this. I already answered it. Okay, that's right. I'm trying to re-record this. So some of them already have answers, I believe. I'll hit similar. Actually, no, I don't have to. So for this question here, it's asking us to determine whether or not this is a polynomial. And I think you guys can see that the powers are all positive whole numbers. So that makes this a clear, winner. It's going to be a polynomial. Now the degree of the polynomial is going to be based on the biggest power. So the biggest power for this problem is 2. So that means it's a polynomial with a degree of 2. Let's rewrite that equation correctly though. The polynomial should be rewritten in what we call standard form, or in decreasing order. So we're going to put the biggest power first and then go down slowly until we reach 0, right? Now, there's only 2 terms, so x squared plus 6x is done. It's asking us what's the leading term. The leading term is the biggest power term, so it's x squared. Now, what's the constant? The constant is going to be whatever it's adding without the variable. Since it doesn't have one, we're going to say the constant is 0. Okay? All right, next question. Okay, good. For this one, is this a polynomial? And I know at first you're thinking, wait a second, this should be, because if you look at it, x is raised to a positive whole number power. But remember, guys, you have to have, for polynomials, you have to have every term as a numerator. So you have to actually take this x and move it up. You got to take this x and move it up as a numerator. The way you do that is you make the power turn negative. So it looks like this when you move it up. And now answer the question. Does this, or is this, and now still a polynomial? And the answer is no, because that exponent is no longer positive. It's negative. So for that reason, we're going to say it's not a polynomial because the power is raised to the -5, which is not a power that's possible for it to be a polynomial. Okay? Still a function, but it's just not a polynomial. Alrighty. Next question. We're moving on. So here, I'm going to erase this for a second. Here we go. All right. So for this question, all we have to do is remind ourselves. Remember, the powers have to be positive whole numbers. So the 3 is perfectly valid, and the 2 is a constant, no big deal. But this particular variable, x to the 7 half, the 7 half is not a whole number. So it's not a polynomial because the power is 7 over 2. Has to be an integer, right? Or a positive integer. So it's not a polynomial. Excellent. Next question. Okay, so they're asking us to graph x to the 4th power. And then when you look at x to the 4th power, we talked about that in a lecture. It looks like a parabola because it's an even, positive, even polynomial. So if I add plus 3 to the x, which way does that translate the graph? This is a chapter 3 question, right? Does it go up, down, left, or right? Now, since the adding 3 is happening inside with the variable x, it's actually going to move left or right, not up or down. And if you guys recall, adding 3 makes it go left, not right. So out of these 4 options, which one did the graph go left? Remember, it starts at 0, and then moves up, down, left, or right. This one went left, so for choice A, you see it went to the right from 0. For choice B, you can tell it went down. Choice C went up. Choice D went left. That's my choice. My answer is D. Alrighty. For this one, so x to the 5th power is basically a cubic function. They all look cubic, right? But the transformation occurred and -1 is outside the variable. That means, is it up, down, left, or right? And if you guys are thinking, oh, it goes down, you're right. It's absolutely correct. It goes down because it's outside the variable, outside the function. So let's see. A looked like it went up. B looked like it went down. The answer should be B, but let's check out C and D just in case. C went to the right, D went to the left, so yeah, B is correct. Alrighty. Number 9. Okay, so we're going to have to do a little bit of rewriting to graph this so we can make sure we have the equation correctly written. It looks, on the face of it, it looks like it's that 2 is negative. A lot of people make that mistake, but that 2 is actually a positive 2. What's negative is this expression, the x minus 3 to the 5th power. That's negative. That 2 is technically positive, right? It's not negative. There's no negative to the left of that 2. So this is how it's better viewed. If you see like this, now you're thinking, oh, okay, now I know what's happening. And if you guys see, this means it's going up, okay? And the -3 inside means it's going right. And this negative outside, I hope you remember, it's a reflection, a vertical reflection because it's outside. A vertical reflection from here to here is over the x-axis. So we're going to say a vertical reflection. Oh boy. Okay, reflection. And what does that mean in terms of the cubic function? Well, if the cubic function used to be like this, and this part here, let me just kind of get a different color. If this part here reflects down here, and that part here reflects up here, then the new graph, I'll do it in green, looks like that. So we know it's going to look like this, what I have it in green, not what's in orange. So we can get rid of A, and we can get rid of C, because it's not reflected. So B and D definitely reflected it. Now, it's supposed to move to the right 3 times. So look at B. It went to the right, D went to the left. We can get rid of D. The answer has to be B. Did it go up just in case? Yes, it did. It went up just a little bit, like it says there. So the answer should be B. So let's find out. B. We're going to check our answer, and it says, well done. So let's clear this up before I move on. Alrighty, next question. Okay, so for this one, we have to recall how to get the equation of a polynomial. Or the solutions, excuse me. How do we normally get the solutions? Well, we would have factors, right? And then whatever will make that factor 0 will be a solution. So if my solution was 1, right? What was the factor that created that solution? Well, if the solution is positive 1, then the factor should have said x minus 1, right? X minus 1, plugging 1 in there gives me a 0. The multiplicity is the power of that factor, so it's the 1 power. Now the next solution is the 2. So if my solution is positive 2, then my factor should have been x minus 2, and the multiplicity, or the degree of that factor, is 2. And voila, we got our equation. This equation will have the 2 answers that they're requiring us to have with the proper multiplicity. And let's see if we got it right. So we're going to go ahead and type this out. We're going to say x minus 1 times x minus 2 raised to the 2nd power. And let's see. It says, well done. Excellent. Let me clear this up before we move on. Next question. All right, so for this one, it's asking us to find the zeros. Now, to find the zeros means to find the solutions for each factor when it's already factored for you, like it is in this case. So the zeros, let's write the equation. Each factor, let's talk about these. So there are three factors you notice here. There's -6, x minus 7, and x plus 8. Now the factor of -6 clearly has no variable, so we don't have to worry about it, we ignore it. But the x minus 7, what can I plug into this factor, this x minus 7? What can x be for this to be 0? You guys are saying 7, you're right. How about for the x plus 8? You guys are also thinking, oh, that's -8. -8 plus 8 is 0. Correct. Those are my two solutions, my two zeros. Okay, so let's go ahead and type that in. We got, what is it, 7 and -8, so let's go and put that. 7, -8, and let's see if we got it right. Fantastic. Let me clear this for a second so we can see that. Fantastic. There you go. Alrighty. Next, the multiplicity of the larger zero. So, and I just erased it. Well, we know that the larger zero is 7. 7 is the larger zero because 7 is biggest. And multiplicity is the power of this factor. So what's that power up there? It's not there, but you know it's 1. So we're going to say 1. Multiplicity to the smaller zero. So out of these two answers, -8 to smaller 0, that came from this factor. And that factor has a power of 2. So the multiplicity is 2. Alrighty. Excellent. Now it says here the graph blank. Oh, I see. So for the larger x-intercept, the larger one is 7. Since the multiplicity is 1, that's an odd multiplicity. Odd multiplicities, remember guys, cross the x-axis. So for this particular one, we're going to say it crosses. And then for the smaller x-intercept, which is the -8 value, that has an even multiplicity. And even multiplicities touch the graph at that point. Touch the x-axis at that point. So how about the max number of turning points? Well, we're going to go ahead and get the degree. The degree would be 1 plus 2, or a total of 3, right? We add those powers. And so then the solution would be 3 minus 1, or 2. You can have up to 2 turning points. 2 or 0, but we're going to say 2 is the max you can have. What is the leading term? So this is a little bit tricky because we know the degree is 3, but what's the coefficient? Well, the good news is, I'm actually going to draw this. I know I've been avoiding it, but when you see this, let me do a different color. When you see this, x minus 7, x plus 8 to the second power, the most you can get out of this is x to the third power, because you have x to the 1 power, right? And x to the second power, so the most will be x to the third. And then eventually you're going to multiply by -6. So it's going to be -6x to the third power. That's going to be the leading term. That's what's going to create the shape of the whole graph. So we're going to go ahead and write that and see what we get. -6x to the third. And it says good job. And next question. Let me clear this up now. All right, so for this one, it says determine whether the graph could be a polynomial function. If it could be, list the real zeros. Okay, let's actually look at the graph for a minute. The graph. For a polynomial graph, at least for it to be a polynomial, it must always have a smooth curve, right? It must always be smooth curved. Eventually, it'll look like this for even polynomials, or like that for odd. Maybe it'll look like this if it's a negative even, or like this if it's a negative odd. But it's always smooth curve. There's no holes, there's no splits, or nothing like that, right? So in this particular graph, I see a smooth curve. It looks perfectly fine. Looks like an odd function to me. So we're going to say, yes, this is definitely going to be a polynomial. Now, what are my zeros? Let's look carefully. My zeros are the x-intercepts, right? So we have 1 here, 1 here, and 1 here. 3 x-intercepts. That's going to be 1, 2, 3, 4 for -4. 1, 2, -2, and +2. Those 3 are my intercepts. The second half of the question is asking me for what degree could I have. Remember guys, degree depends on turning points. I see 2 turning points. So if the maximum number of turning points is the degree minus 1, And I have, that means that the degree could be the number of turning points. I'll put TP plus 1, right? It's just going to be reversed. So if there's 2 turning points, it could have at least a degree of 3. The smallest degree could be 2 turning points plus 1 or 3. Could it have more degrees? Yes, it could, but we're looking for the smallest because we can't see any more than what we have, right? So we're going to say, let's close this off, and let's say the graph shows the polynomial, the zeros are -4, oops, -2, and 2. And the least degree can have, could have bigger degrees? Of course it could, but the least would be 3. Okay. Let's check our answers. It says nice work. Let's clear the drawing board. Alrighty, let's move on to the next question. This question is asking us to determine whether, okay, so let's look at this picture. Is that a polynomial? And you can see a clear break in the graph. Do you guys notice that? This is not possible if this were a polynomial. So this is not a polynomial. So no. Okay. And since it's not a polynomial, we can move on. Alrighty, so for this question, I want us to do a little bit of working backwards here to make this a little faster. We notice that this graph, if you look at it, the ends go up, the end behavior. So it's a parabola, right? Basically, I know it's not here, it's kind of off, right, in the middle. We're going to not worry about that part. We're just going to worry about the ends. The ends go up like a parabola does. What does that mean? It means, and it's going up, remember that, it means that the coefficient of the entire function should be positive, right? If it were negative, it would look like that, wouldn't it? So let's look at A. Choice A, look at that coefficient. What's wrong with it? It's negative, so it can't be A. What's wrong with C? I see C has the same problem, doesn't it? Can't be C. Is there any other question with that issue? No, they all have positive coefficients. Okay, so that one's done. Now we're going to notice that there are 3 solutions. One at -2, one at +2, and one at -4. So the solution for -2 is going to be x plus 2, or the factor rather. And since it crosses the x-axis, the power should be 1. So we notice that d, the power is 2 there. It can't be d. How about the solution for x for 2? That's going to be a factor of x minus 2, right, for its solution to be 2. We notice it's touching the x-axis, not going through. That means the power must be 2 there. Let's see, what's wrong with b? It's missing that power of 2. Can't be b. F has the same issue. So the answer has to be E. There's only one choice left. Let's see if we're right. Let's see if our method worked. And it says, well done. Excellent. To clear the drawing board. All right. So we're going to look at this equation. Okay. The first step, I know it says here there's A through E, so it's a lot of steps. So the first step's asking what's the main term. Now this is an easy one to distribute, so we can do that quickly. X squared times x is x to the 3rd power plus x squared times 9, that's 9x squared. So that's the equation. So what's the main leading term there? You guys are right, it's x cubed. So that one's not too bad. So let's go ahead and type x cubed. Excellent. What are the x-intercepts? Well, to find the x-intercepts, I'd rather use it in this form. So I'm going to go ahead and go back to the drawing board. X squared, x plus 9 equals 0. Remember, the step is to make the equation equal to 0 and solve for x. For this particular factor, the solution is 0. And for this particular factor, the solution is -9. So those are my x-intercepts. You can also call them my zeros. I believe they make you type the answers twice, right? So let's go ahead and put these answers in there. 0 and -9. Alrighty. Check answer. Next question, the y-intercept. Y-intercept means we're going to plug in 0. If I plug in 0 into this equation, I'm going to get 0 times 9, which is 0. Alrighty. So the next problem, the zeros. This is what I mean. They're asking us for the same thing as the, part B. Sorry. Yes, part B, the first half of part B. When it's asking for x-intercepts, that's what the 0 is. It's an x-intercept. So we're going to have the same answers. Alrighty. Now, let's describe what kind of x-intercept this is. So the 0 has a multiplicity of 2, which means it's an even multiplicity, which implies it's going to touch the graph at that point when x is 0. The negative 9 has a multiplicity of 1, which is an odd number, which implies it's going to cross the x-axis at negative 9. So let's see. The lesser 0 of the function, so that's negative 9, negative 9 is the lesser 0, has a multiplicity of 1. So we're going to put 1 there. So let me type this up, 1. So the graph of f at that particular point is going to cross at 1. The x-axis is at x equals negative 9. All right. So the greater 0 of the function has so the greater 0 is 0. So the multiplicity of 0 we earlier figured out it was 2. That implies that it's going to touch the graph at that point when x is 0. Excellent. We're going to check our answers. Okay, great. Next part. What's the maximum number of turning points? Well, we see here that the degree is 3. So remember, the degree minus 1 is the maximum number of turning points. So 3 minus 1 is 2. Alrighty, one more part. Oh, okay, so let me clear this up. Actually, remember guys, it's going to bounce off of 0 or touch 0, and it's going to cross at negative 9. So let's keep that in mind when we clear this up. Look at the choices. So, first of all, the graph is positive and it's odd. So it's going to look like this. Let me draw this up. So immediately I can get rid of B and D. Those do not correctly show the positive nature of this odd polynomial. Second, we know at negative 9, it's going to, I believe it crosses. Let me see. Yeah, negative 9 it crosses. So here it crosses, it looks like it's crossing, and then it's touching at 0. This one looks really good. How about this one? It's touching 0, but it's crossing through positive 9. The issue with that solution is not the solution of that problem. So the answer is going to be A. Okay? So let's go ahead and choose A and see what happens. Fantastic, guys. Fantastic. Right, let's clear this up. So the next question here. It's asking us to see what's the behavior, or at least the one that determines the whole behavior. So if you look at this equation, the one that determines the entire thing would be the leading term. Now let's look at this. This has a degree of 1, right? Because you're going to multiply. Let me actually write this out again. Alrighty. So this is a 1 power. We're going to multiply it. This has a degree of 1, this factor. This is a 1 here. We multiply it. This factor is a degree of 3. When you add up those degrees, you get a total degree of 4. So the x to the 4th power is going to be the largest power. If you don't have to multiply everything out, you're going to eventually get this as the larger power. Now the question is, what's the coefficient? Well, the coefficient to the whole problem is also the coefficient to that leading term. So that's our answer. The leading term is going to be negative 3x to the 4th power. So let's go ahead and do that. Let me type that in there. Negative 3x to the 4th. Alrighty. Oh, this is one of those bunch of parts. Okay, the x-intercepts are, let me clear this so you can see what we're looking at. The x-intercepts are, so for the x plus 4, it's going to be negative 4, and for the x minus 4, it's going to be positive 4. So we know it's negative 4, positive 4. Alright. Next question. The y-intercept, we're going to plug in 0 there. So let's see if I can plug in 0. Ooh, looks like I need a calculator. 0 plus 4 is 4. Let me actually write this out. I'm going to definitely. So it's going to be y equals negative 3 times 0 plus 4 times 0 minus 4 to the 3rd power. So I definitely am going to use a calculator here. So it's negative 3 times 4 times negative 64, right? 4 times 4 times 4 is 64. Okay. And now we're going to multiply that times 4 times 3 So the answer I got is negative, no, sorry, I take it back, positive 768. So that's a giant y-intercept. Let's see if I got it right. 768, and it's fantastic. Definitely need a calculator. The zeros are the same as the x-intercept, so we know it's going to be negative 4 and 4. That's easy. And so let's look at the, I'm going to clear this up for a second. Clear. Alrighty. Let's look carefully here. The smaller zero is negative 4, right? That came from the x plus 4 factor. So the multiplicity of x plus 4 was 1, right? That power was 1. So I'm going to put 1. And then the graph is going to then, cross. Forgive me. It's going to cross, because it's an odd number. It's going to cross the x-axis when x is negative 4. How about the greater 0 with the 4? That came from x minus 4 factor. That multiplicity is 3. So it's also going to cross. Okay. It's going to cross because they're both odd when x is 4. Alrighty. Next one, the maximum number of turning points. So we know that this is going to be the degree, 4. So the maximum number of turning points is going to be 4 minus 1, or 3. Alrighty. So let's see which one makes the most sense. So it's a negative even polynomial because it is raised to the 4th power. Let's look at that. That is the leading term. So it's a parabola going down. We know that because it's even, so it's a parabola, and it's negative, so it's going down. That leaves A and D out of the question. So it's all about the zeros now. At the negative 4, 0, okay, and, well, actually for both cases, they're going to cross. So let's see. They have to cross for both. It's hard to tell. So the only difference between these two is that this one, let me actually play this. This one has a solution at negative 4 and positive 4, with the y-intercept at, looks like 768, I guess. Okay, let's look at the next one. This one says negative 4 and positive 4 with the y. Oh, okay. So in this particular case, guys, we're gonna have to figure out something else, because you notice that they all share the same characteristics. They're going through each of these points, which is perfectly valid. They're going down. They both seem to have the same y-intercept, so there's no apparent difference in terms of the key things we figured out here. So we have to now test the value. Now I will say the biggest difference I see is that at 2 here, the answer is a large value, and that at 2 for the other one, the answer is a small, it's really close to 0, a small value. So in order for us to figure out which is which, I'm going to go ahead and plug in 2 to see which one works. So I'm going to say negative 3, let me actually write this, negative 3 times 2 plus 4 times 2 minus 4 to the 3rd power. Again, to determine whether it's way up here like in C. I'm sorry, I plugged in positive 2, didn't I? Yeah. So it's way down here like in positive C, or way up there like in B. So let's find out. So I suspect it's going to be a pretty big number, but let's find out. So 2 plus 4 is 6, obviously. And 2 minus 4 is negative 2. Raised to the 3rd power is negative 8. So it's going to be negative 3 times 6 times negative 8. Gives me 144. So let's find out which one says 144. If I look at this choice B, when I plug in 2, it gives me way more than 144. It gave me, it looks like, I don't know, 1,000 or something, right? That's too big. C, when I plugged in 2, it looks correct, right? It gives me 144. So that looks correct to me. I'm going to say the answer is C. Oh, C. Let's see if it's correct. Alrighty, nice work. Let me clear this up. Next question. Oh, that's it. We're done. All right, excellent. So this is chapter 5.1 homework. I hope you guys understood all the questions. If you have any other questions or any issues, concerns, let me know, guys. And I'll see you for the next homework.